Okay, Year 11 IB. This is another screencast on transformations. I'm not that obsessed with transformations, honestly. But on the back of today's lesson and some questions that were being thrown around and some things that came out, I thought I might just record another quick screencast here for you. Excuse me, on transformations. I'm also working with the sound quality, and I need to get myself a decent external microphone, so bear with me on that front. Right, so what I've constructed here, just to get things started, is just a sort of a hybrid function defined across different domains differently, as you can see there. But it doesn't really matter what the function is. We're just gonna know it as f of x. And in class I was talking about the three types of transformations, and that is the translation, which we'll have a look at first. So the translation, if we're going to add say 2 to this, a translation at the input level, if we add 2 on to this function, then that's just going to give us a vertical translation. And the way to remember it, Nick did this, brought this up in class. I thought it was quite nice. If we add something or multiply a function externally by a constant, then what we're doing is, I called that a sort of at the output level. Nick referred to it as, well, that changes the y coordinates. The x coordinates are held and the y coordinates change, which I think is quite nice. So if you look at this, every y coordinate for each of these x coordinates changes. So we add 2, these points come into place. So we just bump this whole thing up by 2. How easy is that? And then we've got ourselves a little fx plus 2. Nice. So it's exactly the same. It's a cut and paste. It's a cut and paste up by 2 units. If that was a down by 2, I just backtrack, undo all those bits. How am I going? I don't think I need to do a minus 2, do I? A minus 2 would just come back the other way. So that's at that level. Plus or minus 2 translation in there. So now if we have a look at putting the translation inside, so putting the adjustment, sorry, inside. So we'll have a look now at putting an x plus 2 in here. So what that does, and I talked about it being at the input level making an adjustment, which meant to a left-right shift. A more direct understanding might be gained by looking at, as Nick was suggesting, the y coordinates now stay unchanged, the x coordinates change. So the x coordinates change 2 to the left. So for the same y coordinate, the x coordinate now goes to there for that one, goes to there for that one, 2 to the left. Each of these going 2 to the left. So we have a look here, and what we end up with is a horizontal translation, 2 units. Beautiful. So look at that. It's exactly the same thing, shifted 2 to the left. So what that means is, now for the same values of x, we need to reduce our values of x to get the same values for y. We need to reduce our values of x at the input level to get the same output results. So that's why we have a shift to the left. Okay, so they're the translations. We're going to keep that language up now for our stretches. I think I'm going to skip the reflections because I think they're pretty straightforward. Remember, the minus out here flips around the x, and the minus in there flips around the y. Okay, I'll just backtrack on that. Oh dear. Has that completely disappeared? Sort of. Okay. Just get rid of that. Now, so with our function now, let's have a look at some stretches and what happens there. So let's have a look now at applying a constant and multiplying our function by a constant 2. Now it's external to the function, so it's at the input level. It's to do with it's at the output level. Externally means it's just the function is calculated and then it's multiplied by 2, so it only affects the output level, which means that the values of y change for the same values of x, and they change in that they're doubled here. So I've got a y at this point here. This has got a y coordinate of 1, 2, 3, 4. It's now got a y coordinate of 5, 6, 7, 8. So that point heads up there. This point heads up there. We're going to double. Now that's not going to change. This is minus 2, so it stretches down there. This is not going to change. And this is 1, 2, 3, 4, 5. It's going to go 6, 7, 8, 9, 10 to there. So for the same y coordinates, our x coordinates are double. For the same x coordinates, to reverse that, for the same x coordinate, so x doesn't change, y doubles. So now our function looks like this, and this is called a vertical stretch scale factor 2, and we'll see how that looks. Okay, so that you can imagine that black function just being stretched vertically that way, and we end up with the red function. Okay, so remember vertical, if we multiply outside the function, then it's going to be a vertical stretch. If we multiply inside the function, it's going to be horizontal stretch, and we'll have a look at what changes there. So outside the function, it affects the y coordinates, not x. Inside the function, it affects the x coordinates and not the y. So this is what results here if I have a look at f of 2x. Now what this means is that my x values are halved and my y values stay the same. So my x value here is 1, 2, 3, 4, 5, 6, 7, 8, 9. It now goes to 4.5. 1, 2, 3, 4.5 there. So that point has mapped to that one. This point here, which is at x equals 1, 2, 3, 4, 5, 6, now goes to 1, 2, 3. Goes to there. You can see the compression taking place, 3. So that point goes to there. This point has 1, 2, 3, 4, backs off to 2. This is my x coordinate at 0, so it doesn't change. At minus 4, 1, 2 goes back to minus 2. And 1, 2, 3, 4, 5 goes to 1, 2.5. Y coordinate does not change. Now have a look at this. What's happened there is a horizontal compression. Scale factor 1/2. So the scale factor here is 1/2, 1/2. Okay, so in summary, an adjustment at the output level, so plus on the end, times on the end, results in vertical movement, a translation if it's plus, and a stretch if it's times. X coordinates stay the same on the stretch, the Y coordinates change. If it's inside, on the plus minus, it's a left-right shift, and the X coordinates change, the Y coordinates stay put. On the inside, at the input level, if it's a multiplication by a constant, then it's a horizontal stretch or compression by factor 1 over that constant. Okay, hopefully this has helped clarify a little bit of that for you. Tomorrow's lesson on Friday will be a work lesson to complete all our work on functions, and we'll start a new topic on Monday. I'll see you tomorrow.